I'm Riyaz Papar, a registered professional mechanical engineer and a certified energy manager, and I'm based in Houston, Texas. So there are several and varied industrial and manufacturing processes which require very, very tight control on temperature and humidity or moisture content. The cooling system removes heat energy in these processes to maintain the operations and the quality control parameters which are needed for production to go on without interruption. Sometimes cooling is needed to remove the heat of reaction when a product is made. Sometimes cooling is used to remove process heat and bring the products down to lower temperatures for storage and shipping. And sometimes cooling is used to just maintain the condition, the environment at a certain temperature and humidity so that the overall process that is going on can be maintained. Almost all of the process cooling and industrial refrigeration systems are driven by electric motors and consume a significant amount of electrical energy depending on the type of the industry you are in. And as we know, 75% or more of our electricity today comes from fossil fuels. Hence, there is a strong correlation between the energy consumed by cooling refrigeration systems and greenhouse gas emissions. Improving the energy efficiency of a process cooling refrigeration system will go a long way to reducing the industry's carbon footprint. When you think about the energy used in a cooling system, it comes down to three factors: the cooling demand, the operating hours, and the efficiency of the system. So every plant should make an effort to understand how much process cooling is really needed and at what temperature. That basically defines the cooling load. There is no point in cooling something and then heating it up again, or cooling something to a temperature which is not needed. Most times, the operating hours are fixed by the geography and the manufacturing process schedules that may be there in the plant, but there could be some optimization which can be done, especially if there is batch processing, plant shutdowns, so on and so forth. But the last piece, which is the system efficiency, is really the player, and plant personnel should make a concerted effort to kind of operate the process cooling unit at its best efficiency point at all operating loads. Our process cooling system is exactly like an orchestra with an excellent conductor. And once we see the whole system, we want to try and operate this whole system at its best system efficiency rather than focusing on a individual component. We all have to play a role to create a sustainable planet for our generations to come. Realize that our cooling and refrigeration systems will always be needed and will always be there. So why not make them efficient and do our bit to ensure that these systems continue to run reliably and at the same time minimize our carbon footprint.